look at properties of rational functions, and most specifically, we're going to look at vertical asymptotes and removable discontinuities. In a roundabout way, we've already been talking about vertical asymptotes because vertical asymptotes really link back to the domain that we were previously talking about. And in our box here, a vertical asymptote describes the behavior of the graph when x is close to some specific number. The thing is, it gets close to some specific number, it never quite touches. And the graph of the function never intersects a vertical asymptote because our domain is undefined at that value. It causes us to have some unreal number, not real number. You can determine the vertical asymptote of the graph based on the function if what's undefined in it is what's undefined in the domain, although there's one catch to that. So domain, what happens is we write x does not equal. When we write our vertical asymptote, we write it as x equals some number. And that's confusing for some people. So I want to say it again. For domain, we write x does not equal whatever value is not allowed to equal. And for the vertical asymptote, it's x equals a number. It's an equation of our vertical line. What we have over here in the box beside the box with all the words is we have two pictures here. We've got our vertical asymptote in the dotted kind of pinkish color. And then our graph to either side of it, it gets close to that line, but it never quite touches. Same kind of situation to the right. We still have our x equals c, some number. And then we have another graph that's getting close to, it's approaching that line, but it never quite touches. So when we take a look here at our first example, we've got state the domain of the following rational functions, determine the vertical asymptotes, determine the x-intercepts, use your calculator to confirm your answer, draw a rough sketch of the function, be sure to draw in the vertical asymptote. Well, we're really taking off where we left off from our last notes of finding the domain. And what we said over and over from our last notes in terms of domain is we said that we take the denominator and we set it not equal to 0. And maybe you don't even need to show this step. I don't want to skip it. But maybe you don't even need to show that. You can go directly to the fact that x doesn't equal 2. So that goes here. And what we did in our previous notes is once we found that domain that determined our gap in our graph, so we drew a dotted line. Now that's our gap, but it also happens to be our vertical asymptote. And when we write our vertical asymptote then, the only difference is that we're going to write x equals 2 because it's the equation of that dotted line. Well, eventually what we want to come up with is we want to come up with the picture here. But we also want to identify what's the x-intercept of the graph. In other words, where does the graph cross the x-axis? And what's the y-intercept of the graph? In fact, I'm going to start with what's the y-intercept of the graph. And the way that we calculate out the y-intercept is that we let x equals 0 back in our equation. So x equals 0. If we put that back in there, what we have is we have 0 plus 5 divided by 0 minus 2. And 0 plus 5 is 5, and 0 minus 2 is negative 2. Again, we let x equal 0. And then we came up with negative 5 halves, which, by the way, is the same thing as negative 2.5, if you prefer. And you can put negative 2.5. All of those are the same value. Again, what that is, that's our y-intercept. Over 0, down 2.5. Well, it's a little bit more difficult to find the x-intercept, but not too bad. To figure out the x-intercept, what we do is we let y equal 0. Remember that f of x is another way of writing y. So when we put this back in here, we get 0 equals x plus 5 divided by x minus 2, and I'm going to run out of space. And you can cross multiply on this. What I've seen a couple people do, and I want to just address it here, is you can also multiply this side by x minus 2 and this side by x minus 2. Either way, what's going to happen is we're going to end up with 0, oh, wrong color, 0 equals x plus 5. And we need to solve that. Sorry, I'm running out of room, and you might be too. 0 equals x plus 5. We're trying to find our x-intercept. Sorry, negative 5 equals x. And then we can draw that in on our graph as well. So negative 5. And what happens is that at least allows me to graph part of this graph. I know what part of it's going to look like right away. It's going to look something like that. I do have this typed into the calculator already. And it's going to come up in green. I need to turn it on. So there's the part that I graphed already, and then we have a little bit more. We're just coming up with a rough sketch of the function. So we can put the other half in over here. But once again, a reminder that that vertical asymptote is where the gap is in the graph, which also relates back to the domain. If we take a look at problem number 2, this is where we're going to start. Again, we're starting with the domain again. And the domain is determined by the denominator. So there's some alliteration if you struggle to remember. Domain starts with D, denominator starts with D. And what we can do is we can take the x squared minus 9 and we can set it not equal to 0. Now remember, there's two ways to solve this. We can factor this, or we can just solve. It does not make a difference in your method. I chose to solve this time. Remember, when we take the square root of both sides, we get x doesn't equal plus or minus 3. So our domain, x doesn't equal plus or minus 3. And if we can determine the domain of the function, then we can also determine the vertical asymptotes plural this time. It's x equals 3, but it's also x equals negative 3. And I'm fine if you write x equals plus or minus 3, but I just want to point out the two, that there are two of them. And once we know the domain, and or the vertical asymptote, we can draw them in. And conceivably, what's the hardest part for people is finding the x-intercept or the y-intercept on the graph. Again, I'm going to start with the y-intercept. To find the y-intercept, we let x equals 0 in our equation. So when we come back over here, to let x equal 0, we've got 0 divided by 0 squared minus 9. Well, that gives us 0 over negative 9. And 0 divided by negative 9 is 0. And the nice part about that is in this particular case, not only did we just find the y-intercept, but we also at least found an x-intercept, because 0, 0 not only crosses the x-axis, but it touches the y-axis also. But to find the x-intercept, I want to remind you that we would let y equal 0. So we know one part about this graph, and maybe other parts, but we know that we've got 0, 0 on the graph. So let's look at the picture. This color here, turn it on. And there's a picture to help us draw the sketch. And we'll continue with this on the next video.